Alright, the last 4 days we were looking at four parts of a triangle and where they all would intersect within or outside of that within, outside, or even on the triangles. And the points at which two or more segments meet is called a point of concurrency. And each of those points were given a different name based on what intersected. So, number one, the first one we're going to look at, gives us a picture, and my question is, what is the circumcenter of this triangle? So find the circumcenter. So first we have to ask ourselves, what is the circumcenter? So the circumcenter of a triangle is the point where the perpendicular bisectors meet. So the circumcenter is the point where the perpendicular bisectors meet. And on a right triangle, if the perpendicular bisectors are going to meet, remember a perpendicular bisector, so if we were to sketch it out, this isn't like perfect. The perpendicular bisector is the median, so it's the middle, that midpoint. It's taking the midpoint because it's a bisector, the midpoint and perpendicular. So that would be the bisector of that side because it's the midpoint. This segment's 1, 2, 3, 4, 5, 6, 7. So it'd be about 3.5. 1, 2, 3. So about here. This is all approximate. And so they're going to meet approximately right there. And then this one is going to be whatever the midpoint is of this. And then it'd be obviously perpendicular. So this is what we're looking for, whatever that specific point is. Well, that point is based on what is the midpoint of this segment. So we need to look at what's this coordinate and what is this coordinate and find the actual midpoint. So if we were to look at those, because perpendicular bisector bisects the segment, so it's looking at the midpoint. This point is at -4, 5, and I think some of the problems actually give you the coordinates and ask you to find the circumcenter. So you could graph it if it helps to graph it first, or you could just look at, can I tell what the hypotenuse is based on the figure? Or if I need to, I can still graph it and then decide. So here's my point here. And then my point down here is at -2, -2. And I'm going to find the midpoint because I'm finding the perpendicular bisector. So x, add the x's together, so -4 plus -2, and that's going to equal a -6 divided by 2, which is a -3. And then we have 5 plus a -2, which equals a -3, divided by 2, which equals a -1.5. So my circumcenter is at a -3, -1.5. Because the circumcenter is the point where the perpendicular bisectors meet. So I needed to find the bisector of the hypotenuse when it's a right triangle. Alright, my next question gives me this figure and asks me to find the value of x. Well, what's happened is I have a incenter. And I know it's an incenter because I have an angle bisector here, I have an angle bisector here, and I have an angle bisector here. They met, and at the point of concurrency, they are equidistant from the sides. So if they're equidistant from the sides, I know that this length is equal to this length. So in the end, I know that 4x minus 1 is actually equal to 6x minus 5. And I can solve for x. Negative 1 is equal to, I subtract 4x from both sides, 2x minus 5. Then I'm going to add 5 to both sides. 4 is equal to 2x. So 2 is equal to x. Now the reason I did that again is because here I have angled bisectors and they're meeting at a point of concurrency called the incenter. Well, the incenter is equidistant from the sides of the triangle. So I was given 4x minus 1 here, and I'm given 6x minus 5 there. If this really is the incenter, which it is because that's what we're given, but based on this picture, I have 4x minus 1 equal to 6x minus 5. The last one has to do with last two have to do with medians and altitudes. The point of concurrency when two medians intersect is called a centroid. Did I say that right? And the point when two or more altitudes intersect is called the orthocenter. So it looks at AP and says, is AP a median or is AP an altitude? So AP is from here to here. And we need to ask ourselves, where is that segment going? It's going from a vertex to the midpoint of the opposite side. That is called a median. If that median is 18, what is KP? We know something about this part. We know that from the vertex to the centroid, so A to K, is equal to 2/3 the whole median. So what's left over is actually 1/3. So we know that KP is equal to 1/3 of AP, which actually is 18. So 1/3 of 18 is 6. And then it looks at BK and KQ. And if I look at that, this is also a median because we're going from the vertex to the midpoint of the opposite side. I know it's a midpoint because the hash marks are the same. That means they're equal. So this is a median. If BK this time, they're giving us this part. They're giving us from the vertex to the centroid is 15. Well, we know that BK is equal to 2/3 the length of its total median, BQ. Well, in this figure, they gave us BK. So 15 is equal to 2/3 of BQ. Oh, sorry, I keep saying, yeah, BQ. Multiply by 3/2. So 45 halves, or 7.5? No. $22.5 is equal to BQ. That's the whole length, and I already know that part of it is 15, so I can take 22.5 minus 15, and I am left with 7.5. That means this remaining part for KQ is 7.5. It asks in the figure over here, what two segments are altitude? Well, at first glance, looking at it, they didn't give us from a vertex to an opposite side being a right angle. Neither one of those are right. Well, if I look, it's a right triangle. So, from the vertex to the opposite side, or a part of the opposite side, a right angle is formed. AC would be an altitude. So would BA. Last problem. Find the orthocenter. So at 1, 1, there's a point A. At 3, 4, there's B. And at 6, 1, there's point C. The orthocenter is the point where the altitudes intersect. Now, to be an altitude, you start at a vertex and you move towards the other side to form a right angle. So, if I were to extend any of these lines, very carefully, that was really bad though. The orthocenter is going to be found by finding the perpendicular line to that current line. So if I were to find the perpendicular of this line, it's going to be vertical. If I were to look at these two, they actually form Okay, so we need to use some algebra. So, we need to find the equation of a line perpendicular to a given line, but it has to go through a point opposite it. So we're given 3 different points, and we need to do it 3 different times to find the orthocenter, because it's the place where they intersect. So if we were to start here with 1, 1, and work towards the other side, we need to know what the slope of this line is. Well, it's going down 1, 2, 3, and over 1, 2, 3. So the new line is going to have a slope of, I'm going to explain this one when I'm in person because this is going to be too difficult to explain over this using my mouse or using my finger pad, and it's going to be easier with the board and being able to write with the actual pen and not the mouse and the cursor. So I apologize.